Hello dear students, I welcome all of you again on this online platform. So just wait for 1 or 2 minutes and then we will start our today's lecture. So right from today, so your attendance will be marked through Google Form link. So I will send that link in this chat. So anytime in between the lecture, and then you have to submit your attendance through Google Form. So those who are not aware of this, so just convey this message to everyone. So in our previous lecture we have discussed about the phenomena of radioactivity and how this radioactive decay it happens, and we have talked about the half-life period of a substance, mean life, and then we have talked about the beta decay. So all three type of beta decay it can happen, and what is the probability for each type of beta negative decay, beta positive decay, or electron capture process. So in this lecture we will discuss the important numericals so which can come in competition exams, so related to half-life. So we will just focus this lecture related with mostly beta decay and about the alpha decay and the Geiger-Newton law and how the process of alpha decay it happens, that we will do somewhere in our next lecture. So let us start important problems related with this. So first problem is uranium 238 decays with a half-life of 4.1 into 10 raised to power 9 years. The decay series eventually ending at lead 206. Uranium is being decayed and it end up to the lead, so which is a stable radioactive substance. So a rock sample analysis show that the ratio of number of atoms of lead to uranium is 0.0058. Assuming that all the lead has been produced by the decay of uranium 238 and all other half-life is the chains are negligible. So we are just considering that. So uranium 238 it is completely decayed into 206 lead only, and we have to calculate the age of rock sample. Now ਜਿਹੜੀ ਸਾਨੂੰ ਦਿੱਤਾ ਕੀ ਇਹਦੇ ਵਿੱਚ ਹੈ, ਸੋ ਸਾਨੂੰ ਦਿੱਤਾ ਹੋਇਆ ਹੈ ਹਾਫ ਲਾਈਫ ਆਫ uranium that is 4.51 into 10 raised to power 9 years. So from this we can calculate decay constant. So lambda, which is equal to 0.693 over T half. So 0.693 over 4.1 into 10 raised to power 9 year inverse. So if you read the statement carefully, so it is saying that the ratio of number of atoms of lead to uranium is 0.0058. So a rock sample analysis shows ਕਿ ਉਹਨਾਂ ਨੇ ਸੈਂਪਲ ਜਿਹੜਾ ਆ ਉਹ ਬਾਅਦ ਚੋਂ ਲਿਆ ਆ। ਸੋ ਉਸ ਕੇਸ ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਰੇਸ਼ੋ ਸਾਨੂੰ ਦਿੱਤੀ ਹੋਈ ਆ lead over uranium which is remaining at that time, so when the sample is being collected, so the ratio is 0.0058. So from that we can say that lead will be equal to remaining uranium multiplied by 0.0058. At that time if we talk about the टोटल नंबर ऑफ यूरेनियम एटम कि जदों ये सैंपल लिया गया सो उस केस दे विच टोटल नंबर ऑफ यूरेनियम एटम्स वो किन्ने होंगे सो दैट विल बी इक्वल टू लेड प्लस remaining uranium, so it comes out to be 1.0058 times this uranium remaining. So from that we know the formula which we have calculated, Ne, that is the number of atoms which are being left, so N naught, that is equal to the total number of atoms which are just at the beginning exponential of minus of lambda t. So this is the formula which we have discovered yesterday. Ne is the remaining number of atoms and N naught is the total number of atoms. So similarly for this uranium case, remaining uranium over total uranium number of atoms which are present, that is equal to exponential of minus of lambda t, and from that you can put these values. So if uranium remaining is 1 and at that time total uranium atom, so that is equal to 1.0058 times of exponential of minus lambda t. So lambda we will put which we know, and from that we can calculate the value of t, so which will be equal to minus 1 over lambda log of 1 over 1.0058. So putting the value of lambda, so minus 4.51 over 0.693 into 10 is to power 9 times log of 1 over 1.0058, and when you calculate it, so this ratio it is coming of the order of 38 into 10 is to power 6 years. So this will be the total age of this rock sample. So correct option is option A. So moving toward the next question. So this question is, which of the following radioactive decay chain is possible to observe? Now if you look at these given options, ਹੁਣ option ਕੀ ਆ ਕਿ ਸਾਡੇ ਕੋਲ ਜਿਹੜਾ ਆ alpha decay ਦੇ ਵਿੱਚ ਅਸੀਂ ਪੜਿਆ ਸੀ ਕਿ when there is a alpha decay, so mass number, so for alpha decay mass number ਜਿਹੜਾ ਆ it decreases by 4, while the atomic number Z it decreases by 2, while for beta minus decay we have studied that the atomic number it increases by 1, so and A remains same. Now if you check this given options, so पहले केस ਦੇ ਵਿੱਚ ਕੀ ਹੈ कि lead ਜਿਹੜਾ ਹੈ ਉਹ decay ਕਰ ਰਿਹਾ ਹੈ mercury ਦੇ ਵਿੱਚ, so 82.206 to 80.202, so then it is decayed into gold, that is 79.202. So second option, if you check here, bismuth which is being decayed from 83 to 210 to 84, so ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਉਹਦਾ ਮਾਸ ਨੰਬਰ ਆ ਉਹ 1 ਵੱਧ ਰਿਹਾ ਆ, so this will be a beta minus decay for first case, and ਦੂਸਰੇ ਕੇਸ ਦੇ ਵਿੱਚ ਤੁਸੀਂ ਦੇਖੋ ਕਿ 84 ਤੋਂ 82 ਹੋ ਰਿਹਾ, 210 ਤੋਂ 206 ਜਿਹੜਾ ਆ ਹੋ ਰਿਹਾ, so ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ ਜਿਹੜਾ decay ਹੋ ਰਿਹਾ ਹੈ that is alpha decay. So correct option is option B. So दूसरी ਤੁਸੀਂ ਇਹ ਵੀ ਚੈੱਕ ਕਰ ਸਕਦੇ ਹੋ 88 to 86, and this is a alpha decay, while 86 to 82, so there is a decrement of atomic number by 4, So this reaction is not possible directly, so this option cannot be possible. So moving toward the next question. So question is, radioactive sample has its half-life equal to 60 days. Calculate its disintegration constant. Second, then calculate its average life. And third, the time required for 2/3 of the original number of atoms to disintegrate. And fourth, we have to calculate the time required or time taken for 1/4 of the original number of atoms to remain unchanged. So in the first option we have to calculate the disintegration constant. So what is given? T half, that is given equal to 60 days. So lambda we can calculate, that is the decay constant, or in some books we also call it as disintegration constant or decay constant. It is one and the same thing. So that is lambda. So disintegration constant, that will be equal to 0.693 over T half. So putting these values, you can find it is 0.01155 day inverse. So this will be the decay constant. And second, we have to calculate the average life, average time or mean time. It is one and the same thing. So average time or mean time, so this is one and the same thing, and this mean time, it is equal to 1 over lambda. So this will come out to be 0.01155. So mean life, average life will be equal to 86.58 days. So this will be the average life of that radioactive sample whose half-life is equal to 60 days. So third, it is said that we have to calculate the time required for 2/3 of the original number of atoms to disintegrate. कि किन्ने टाइम दे विच जिहड़ा आ 2/3 जिहड़ा आ ओरिजिनल नंबर जिहड़ा रह जाएगा. So n over n naught. So number of disintegration जिहड़ी आ वो किहदे बराबर आ? So let us write it some this way. So number of atoms to be disintegrated, that is 2/3 n naught. So number of remaining साडे कोल किन्ने रह जाणगे? So number of remaining atoms, that will be equal to 1/3 n naught. सो जिहड़ा फार्मूला आपां लिखदे आ, सो ओहदे विच आपां हमेशा रिमेनिंग नंबर दे कंपैरेटिव जिहड़ी आ वो रिलेशन जिहड़ा आ ओनू पुट करदे आ. सो रिमेनिंग नंबर n over n naught. So putting in this value, so n remaining is 1/3 times n naught, which is equal to n naught e raised to power minus of lambda t. So lambda t comes out to be log of 3. So t we have to calculate, lambda we know. So putting the value of lambda, which is 0.01155, so t comes out to be equal to 95.1 day. So at this time, so जिहड़ा 2/3 जिहड़ा टोटल पोर्शन आ वो डिसइंटीग्रेट कर जाएगा ते 1/3 जिहड़ा नंबर ऑफ एटम्स दे विल लेफ्ट remaining. So in the fourth option, so it is said that time taken for 1/4 of the original atom to remain unchanged. So इस केस ਦੇ ਵਿੱਚ ਸਾਨੂੰ n/n0 ਜਿਹੜਾ ਆ ਉਹ ਕਿਹਦੇ ਬਰਾਬਰ ਦਿੱਤਾ ਹੋਇਆ 1/4 of the original atoms to remain unchanged. ਰਹਿ ਕਿੰਨੇ ਗਏ ਜਿਹੜੇ unchanged ਆ that is equal to 1/4. So ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ putting it this value, so 1/4 it is equal to exponential of minus lambda t. So t we can calculate from this, that is equal to log of 4 over lambda, and this comes out to be 120 days. So this is how we can solve such problem. So you need to understand what is said in this equation. So पहली जी थर्ड ऑप्शन आ उन्होंने कहा सी कि टाइम रिक्वायर्ड कितना आ फॉर 2/3 ऑफ द ओरिजिनल एटम्स, तो दूसरे विच जिहड़ा आ 1/4 ओरिजिनल एटम विच इज रिमेन अनचेंज्ड. So you remember this relation and then you can convert. So what is given, whether remaining is given or the number of atoms which are being disintegrated. So moving toward the next question. So next question is, a radioactive substance disintegrate for a time equal to its average life. Calculate the fraction of original substance disintegrate. So first option ਜਿਹੜੀ ਆ ਉਹਦੇ ਵਿੱਚ ਸਾਨੂੰ ਕੀ ਕਿਹਾ ਗਿਆ ਆ ਕਿ ਜਿਹੜਾ सबसटांस आ जिहड़ा डिसइंटीग्रेट हो रहा है किन्ने टाइम लिए आपां कैलकुलेट करना है. सो टाइम इक्वल टू इट्स एवरेज लाइफ. सो एवरेज लाइफ का जिहड़ा टाइम आ जिन्हों आपां टी बार दे नाल रिप्रजेंट करते हैं, सो दैट इज इनवर्सली प्रोपोर्शनल टू डिसइंटीग्रेशन कांस्टेंट. सो व्हेन टी बार इट इज इक्वल टू 1 over lambda, so our relation becomes n over n0, that is equal to exponential of minus lambda into t. So putting the value of t, so that will be equal to minus lambda into t bar, so that exponential of minus lambda into 1 over lambda, so it comes out to be exponential of -1, so whose value is 0.368. So the fraction of the original substance which is being disintegrated, so that will be equal to n is equal to n0 0.368. So second jada part आ उहदे विच what they are saying, the half life of radon is 3.82 days. What fraction of freshly prepared sample of radon will disintegrate in 10 days? कि कोई substance आ radon जे उहदा half life 3.82 दिन है, सो 10 दिनां दे विच जिहड़ा आ वो किन्ना जिहड़ा sample आ वो disintegrate जिहड़ा कर जाएगा. So in this T half, that is 3.82 days, and from that we can calculate the value of lambda. So lambda comes out to be 0.693 over t half, so that is equal to 0.693 over 3.82, that is equal to 0.181 day inverse. Now p दूसरा जिहड़ा 10 दिनों ਦੇ ਵਿੱਚ ਆਪਾਂ ਜਿਹੜਾ डिसइंटीग्रेशन किन्नी हो रही है वो फ्रैक्शन ਆਪਾਂ फाइंड आउट करना है. So n over n0, that is equal to exponential of minus of lambda into t. So exponential of minus lambda, which is 0.181 into t, that is 10 days. So its value is minus 1.81, so which is equal to 3 over 20. So fraction jada ya, this is the remaining fraction. So किन्ना fraction jada ya वो disintegrate कर जाएगा. So fraction disintegrate So that will be equal to total minus 3/20. So 70/20 fraction will disintegrate in 10 days and 3/20 will get remained. So next question, the half-life of any unknown substance UX1 is 24.1 days. How many days after UX1 has been isolated will it take for 90% of it to change to UX2? ਕਿ ਇੱਕ ਜਿਹੜਾ ਸਬਸਟੈਂਸ ਆ ਜਿਹਦਾ ਹਾਫ ਲਾਈਫ 24.1% ਆ ਕਿੰਨੇ ਦਿਨਾਂ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਉਹ 90% ਜਿਹੜਾ ਸਬਸਟੈਂਸ ਆ it will get decayed and change into UX2 substance. So T half life, that is 24.1 days. From this we can calculate the disintegration constant 0.693 over T half. So it comes out to be 0.0287 day inverse. ਹੁਣ 90% ਜਿਹੜਾ ਕਹਿੰਦਾ ਉਹ disintegrate ਕਿੰਨੇ ਚਿਰ ਚ ਹੋਏਗਾ? So amount disintegrated ਉਹ ਕਿੰਨੀ ਹੋਗੀ? That is equal to 90%. So which is 90/100. So remaining amount ਜਿਹੜੀ ਆ ਉਹ ਕਿੰਨੀ ਰਹਿ ਗਈ ਬਾਕੀ? Substance which is get remained, that is equal to 1/90 minus 100, that is equal to 1/10, and this is our actually N/N0 ratio. So lambda we know, N/N0 ratio we know, and from that we can calculate ਜਿਹੜਾ ਆ ਉਹ ਕਿੰਨੇ ਟਾਈਮ ਦੇ ਵਿੱਚ ਜਿਹੜੀ ਆ ਉਹ 90% disintegrate ਕਰ ਜਾਏਗੀ. So N/N0, that is equal to exponential of minus lambda into T. So N/N0, that is equal to 1/10. So T comes out to be, ਇਹਨੂੰ ਆਪਾਂ ਇੱਧਰ move ਕਰ ਲਈਏ, so log of 10. So this we can also write 1/exponential of lambda T. So taking the logarithmic value on both sides, so this comes out to be log of 10 over 0.0287. So log of 10, that is equal to 2.3026 over 0.0287. So T comes out to be equal to 80 days. So in 80 days 90% of the substance UX1 it get decayed and 10% of this substance it will get remained. So this is almost the same question, but there is some sort of change or some sort of trick in every statement. So you need to understand the statement in order to solve such problems. So moving toward the next question. So next question is half-life of radioactive K40 substance is 1.83 into 10⁸ years. So find the number of beta particles emitted per second per gram of K40, assuming decay constant is 1.27 into 10⁻⁻17 second inverse and Avogadro number is 6.02 into 10⁻23. Now what we have to find is number of beta particle emitted per second per gram from this radioactive substance K40, potassium 40. So ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ Suppose Nt, that is the number of atoms of potassium 40 which are present in 1 gram. So at any time t, so कितने number of atom ਜਿਹੜੇ ਆ ਉਹ present ਹੋਣਗੇ, Avogadro number over atomic mass, so that is 6.023 into 10 is to power 23 over A, that is 40. So from this you can calculate dNt over dt, that is equal to lambda into Nt. So this is the number of particles emitted per second. So putting these values, lambda, that is 1.2 into 10 is to power minus 17, Nt, so whose value is 6.023 into 10 is to power 23 over 40, so that is equal to 1.8 into 10 is to power 5. So number of atoms emitted per gram per second of potassium 40 is 1.8 into 10 is to power 5 number of atoms which are emitting this number from 1 gram of potassium per second. So next question is, it is observed that 3.67 into 10 is to power 10 alpha particles are emitted per gram of radon 2 to 6. Now the ratio that is given, so calculate the half-life of radon 226. So you can calculate the total number of atoms which are present in 1 gram of radon. So 1 gram of radon 226 having number of atoms that is equal to 6.023 into 10 is to power 23 over mass number of radon, that is 226. So of these, how many are being emitted? 3.67 into 10 is to power 10 alpha particles, they are being disintegrated. So decay constant, so lambda so that will be equal to dN over dt over Nt. So that comes out to be, you can write, so you can use this same equation and lambda comes out to be 3.67 into 10 is to power 10 over dN over dt, that is 6.023 into 10 is to power 23 over 226. So this will be equal to second inverse. So once you find out the value of lambda, that is the decay constant, then you can find out the half-life period T half, that is equal to 0.693 over lambda. So from using the same equation, T half we can calculate, that is 0.693 into 6.023 into 10 is to power 23 over 3.67 into 10 is to power 10 into 226. and this comes out to be 1595 years. So students, if you are not following or you have any doubt, you can ask in the comment section. So next question is, a large amount of radioactive material of half-life 20 days got spread in a room, making the level of radiation 40 times the permissible level of normal occupancy. ਕਿਸੇ रूम ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਆ ਇੱਕ ਰੇਡੀਓਐਕਟਿਵ ਸਬਸਟੈਂਸ ਜਿਹੜਾ ਪਿਆ ਆ ਜਿਹਦਾ ਹਾਫ ਲਾਈਫ ਕਿੰਨਾ ਹੈ 20 days and the level of radiation, so that is 40 times the permissible or the tolerance level of the normal occupancy. So after how many days would the room be safe for occupation? कि जे ਆਪਾਂ ਉਹ रूम ਨੂੰ खाली ਛੱਡ ਦਈਏ तो किन्ने दिनों बाद ਜਿਹੜਾ ਆ सो ਉਹ ਜਿਹੜਾ रूम ਆ ਇੱਕ ਸੇਫਲੀ ਉਹਨੂੰ ਆਪਾਂ यूज कर सकते हैं। ਹੁਣ ਇਸ ਕੇਸ ਦੇ ਵਿੱਚ so what we have to find the value of t, how many days, so we have to find the value of t, so we will use the same equation twice. So once to find the value of lambda, that is the decay constant, and then we will use the same equation, put the value of lambda, and from that we can find out the value of t. So let after t days the room would be safe. So ਜਿਹੜੀ ਆਪਾਂ t ਦੀ value ਜਿਹੜੀ ਆ ਉਹ find out ਕਰ ਦਿੰਨੇ ਆ। So t ਕੀ ਹੈ ਜਿਹਦੇ ਚ, so the time in which the room would be safe for occupation, or you can say that the activity would drop down to 1 over 40 times of its initial value. So n over n naught jeda hai, so that is equal to 1 over 40. So this is given. So from this relation, so putting the value, you can find half life jeda hai wo ditta hoya sanu, that is 20 days. From that you can find the value of lambda, that is 0.693 over 20, and using the relation n over n naught, that is equal to exponential of minus into lambda t, so you can find out the value of this t. So n over n naught, that is equal to 1 over 40, which is exponential of minus 0.693 over 20 into t. So this equation comes log of 40, that is equal to 0.693 over 20 into t. So from this you can find the value of t. So t comes out to be 20 into log of 40 over 0.693. So log of 40, so this comes out to be 106.4 days. So that is around after 107 days, so we can reuse that room, so that would be safe to use after 107 days. So just 10 more minutes and then we will close our lecture. So in the next question, so it is saying the half-life of uranium-238 is 4.51 into 10 to power 9 years. What percentage of uranium that existed 10 to power 10 years ago still survives? ਹੁਣ ਕਹਿੰਦਾ ਕਿ ਸਾਨੂੰ ਯੂਰੇਨੀਅਮ ਦਾ ਹਾਫ ਲਾਈਫ ਦਿੱਤਾ ਹੋਇਆ कि ਜਿਹੜਾ यूरेनियम ਦੀ परसेंट ਜਿਹੜੀ ਆ ਜਿਹੜਾ 10 ਸਾਲ 10 ईयर अगो ਜਿਹੜਾ ਆ ਉਹ ਕਿੰਨਾ ਸਰਵਾਈਵ ਜਿਹੜਾ ਆ ਉਹ ਐਟ ਪ੍ਰੈਜ਼ੈਂਟ ਉਹਦੀ ਵੈਲਿਊ ਜਿਹੜੀ ਆ ਉਹ ਕਿੰਨੀ ਹੋਏਗੀ ਜੇ 10 ਦੀ ਪਾਵਰ 10 ਸਾਲ ਪਹਿਲੇ ਜੇ ਆਪਾਂ ਉਹਨੂੰ ਕੰਸੀਡਰ ਕਰੀਏ ਕਿ ਉਸ ਪੁਆਇੰਟ ਤੋਂ ਜਿਹੜਾ ਉਹ ਡਿਸਇੰਟੀਗ੍ਰੇਸ਼ਨ ਉਹਦੀ ਸਟਾਰਟ ਹੋਈ ਹੈ। ਸੋ we can find the value of disintegration constant 0.693 over T half. So 0.693 over 4.5 into 10 raised to power 9 . Now suppose if N naught is number of atoms of uranium, they are at 10 raised to power 10 year ago. So now present ਜਿਹੜੀ ਉਹਦੀ value ਆ so ਉਹ ਕਿਹਦੇ ਬਰਾਬਰ ਹੋਏਗੀ n will be equal to n naught e raised to power minus of lambda t. So where t is 10 raised to power 10 years, that is given just a minute. So from this you can find the ratio of this n over n naught, that is e raised to power minus of lambda t, and logarithmic value of n over n naught, so that is this comes out to be lambda t. So ਇਹਨੂੰ ਜਿਹੜਾ ਆਪਾਂ logarithmic 10 ਦੀ ਫਾਰਮ ਦੇ ਵਿੱਚ ਕਿਸ ਤਰ੍ਹਾਂ ਲਿਖ ਸਕਦੇ ਹਾਂ log of e ਨੂੰ, so that is 2.303 log of 10 n over, so here there is a negative sign, so this get reversed, so this value is n naught over n. So log of n naught over n, that is equal to lambda t. So putting these value 0.693 over 4.5 into 10 raised to power 9 into t is 10 raised to power 10. So from this log of 10 n naught over n, this comes out to be, so if you move this 2.303 to the denominator value, so this side, so this comes out to be 0.6673, and from that you can take the value of n naught over n, that will be equal to antilog of 0.6673, so that is equal to 4.648. So ratio ਜਿਹੜੀ ਆ n over n naught ਦੀ ਜਿਹੜੀ ਆਪਾਂ find out ਕਰਨੀ ਆ ਕਿ ਜਿਹੜਾ at present ਕਿੰਨਾ survive ਕਰਦਾ, so at present ਜਿਹੜਾ ਆ so that is equal to 0.215. so if n naught of n is this, so when you reverse this, so it comes out to be 0.215. so percentage of uranium that is present, that is around 21.5% times n naught. so ਜਿਹੜਾ at present ਕਿੰਨਾ uranium ਜਿਹੜਾ survive ਕਰ ਰਿਹਾ ਹੈ, that is 21.5%. So moving toward the next question, the half-life of radioactive substance is 5 hours. What will be its 1/3 lifetime? ਉਹਦੀ ਜਿਹੜੀ ਆ ਹੁਣ lifetime ਜਿਹੜਾ ਆ ਉਹ ਕਿੰਨਾ ਹੋਏਗਾ, 1/3 ਜਿਹੜਾ ਰਹਿ ਜਾਏਗਾ. So T half is 5 hours. So from this you can find the value of lambda 0.693 over T half is 5 hours, so that is 0.1386 hour inverse. So one third ਜਿਹੜਾ ਉਹ ਸਰਵਾਈਵ ਕਰ ਰਿਹਾ, so that is n over n naught, that is equal to 1 over 3. so we have to find ਕਿ ਜਿਹੜਾ ਆ ਉਹ ਕਿੰਨੇ ਟਾਈਮ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਇੰਨਾ ਰਹਿ ਜਾਏਗਾ. so using this formula n over n naught, that is equal to exponential of minus lambda t, so this comes out to be 1 over 3, that is this becomes 3 of, so if I write this, that is 3 is equal to exponential of lambda t, so log of 3, that is equal to lambda t, and from this you can find the value of t, log of 3 over lambda, so that is equal to 2.303 log of 3 over lambda, that is equal to 0.1386. so this comes out to be 7.93 hours. So this is the last question of today's lecture. So just a minute, I will send you the link of attendance. So the question is, the activity of certain radionuclide decreases to 15% of its original value in 10 days. Find its half-life. So if n naught is its original value and n is the amount left, so किन्नी जड़ी वैल्यू आ और रह रही है, that is 15%. so what does it mean? so n over n naught, that is equal to 15% or 15 over 100. t is given, and from this we can find the value of lambda. so n over n naught, that is exponential of minus lambda t, so that is 15 over 100 is exponential of minus lambda into 10, so this becomes log of 100 over 15, that is equal to 10 lambda. so lambda comes out to be 1 over 10 log of e 100 over 15, so that is equal to 0.1897, and once you find the value of lambda, from that you can find the value of half-life period 0.693 over lambda, so that is equal to 0.693 over 0.1897, so it comes out to be 3.65 days. So this is all about today's lecture. So in our next lecture we will start the very important article of nuclear physics, that is the shell model and its applications. So till then, goodbye. If you have any doubt or any queries, you can ask me in the comment section, or you can also ask me personally on WhatsApp group. So okay dear students, have a nice weekend. See you in next week. Till then, goodbye, take care.